Next, I have the privilege to introduce our fourth and final award this morning, the Susan Mahan Niebur Early Career Award. The 2019 Susan Mahan Niebur Early Career Award is an annual award given to an early career scientist who's made significant contributions to the science or exploration communities. Recipients of the Susan M. Niebuhr Early Career Award are researchers who are no more than 10 years from receiving their doctorate and who've shown excellence in their field and demonstrated meaningful contributions to the science or exploration communities. Susan Mahan Niebur, who lived from 1978 to 2012, was a former Discovery Program scientist at NASA who initiated the first ever Early Career Fellowship and the annual Early Career Workshop to help new planetary scientists break into the field. There couldn't be a finer woman to have as the namesake for this award. This year, the prize is presented to Dr. Debra Needham, planetary scientist at NASA's Marshall Space Flight Center in Huntsville, Alabama. Dr. Needham has investigated surface processes such as volcanic eruptions and lava flow emplacement on the Moon, Mars, Venus, and Earth. She's also worked with several teams of engineers to integrate science into developing exploration opportunities, such as the Deep Space Gateway and lunar surface missions. She earned her BA in geology from Pomona College in 2007, her MS in geosciences from Brown University in 2009, and her doctorate in geosciences from Brown University in 2012. Dr. Needham joined the Heliophysics and Planetary Science Group at Marshall Space Flight Center in 2016, where she continues her research of volcanic eruptions on Earth, the Moon, Mars, and Venus. This work is leading to new exciting investigations and discoveries that is going to influence future missions to the lunar surface. And I'll also add that she has had some very impactful papers in the recent that I just love to read and really treasure. So Deb, if you wouldn't mind coming up, congratulations.
Greg, thank you very much for that, and SSERVI Central as well for this great honor. Susan's legacy is, to me, from my perspective, is her passion and her dedication for inclusion, particularly for early career scientists. But she also, beyond just early career scientists, she elevated those around her to perform their best and to be the best that they could be, not only with their work, but also outside of work, developing a strong and healthy work-life balance. So I very much appreciate the honor of this award and look forward to continuing Susan's legacy in my career going forward. As Greg said, my career started mostly focused on the science part of research, looking at volcanism and volcanic processes on multiple planets. As I chose to focus on a process rather than a planet because we were told early on, I guess in my career, I was still a grad student, when we were told that you don't want to be an insect. Insects kind of, you don't want to be focused on single planet because you don't know what the direction NASA is going to go. You don't know where the money's going to go. You don't know where the focus is going to go. So if you are focused on a process rather than a planet, you are setting yourself up for success. And so I really tried to embody that, focused on a process that happens on as many planetary bodies as we can find, including the icy planets with cryovolcanism. But over the course of my career, I started to realize that I had a very distinct passion for integrating science into exploration. And so I looked for opportunities where I could use my passion and my dedication to do the best that I could do, be the best that I could be for integrating science into exploration. So moving forward with my career, and most recently, I've been really focused on finding opportunities to do that and provide meaningful contributions to the field and advocating for all of science, not just planetary science, but all of science in exploration going forward. So I wanted to talk about a couple lessons that I've learned for myself along the way that hopefully help at least some of the early career folks in particular in the room and online. The first one is any career, life in general is one of the biggest challenges that I face is making decisions. Sometimes, you have to make decisions. You're going to have to make decisions throughout your entire life, as Jen was saying. Decision making from leadership is very important, but it's also really important in your own life to make decisions. And you're not always going to have all the data in hand to make tough decisions going forward. And that can be really scary. You don't know what's going to happen when you make your decision, so you have to accept that, make your decision, go forward, and don't look back. Don't doubt yourself. Just go forward, push forward. Make adjustments along the way if you need to, of course, but make your decision, be confident in that, even if you don't have all the data in hand. The second lesson, and this is really very important for the early career people in particular, is speak up. When you notice something, when you make an observation in an image or in a data product or on a spacecraft, you have to speak up. Don't assume that other people are going to see what you're seeing. It's really important. Your perspective, your unique input is very important to furthering a conversation. So I really encourage you to speak up. It's not always easy when you're in a room full of very experienced and people that you respect and know that they have more experience than you do, but it doesn't matter. Your perspective is unique and valuable, so speak up and contribute. And so going forward, so I wanted to also talk about a little bit of my experience recently with specifically science integration into exploration. One of the projects that I've been working on is related to the NASA Next Step broad agency announcement to commercial entities to provide inputs and designs for a prototype and actually build a prototype for habitats that we might fly around the moon, around the lunar, in orbit around the moon. And so I was asked as a science subject matter expert to provide some procedures for crew in particular to perform over a 2-day simulation to test these prototypes, these habitat designs, trying to figure out how well these designs work, allow a crew to live and work in space, and particularly work. So what I was tasked to do is choose science objectives that we could address, have a team write the procedures, and then sit on console and monitor the crew operations and make sure that what they were performing are procedures and the science that we wanted them to perform in simulated environments, but also how they were able to conduct their tasks with the design at hand. So one of the things that, the very first place that I wanted to start was going back to the Gateway Science Workshop that we had a year and a half ago and pull the inputs from the community. This input is very important and it does survive. I mean, we do use those inputs going forward. So I went to that workshop, the results and the discussions that happened there, and picked out some of the key procedures and the key science objectives that we wanted to perform, that you told us that we wanted to perform. Most of them involved crew. Some of them didn't because the Gateway's not always going to have crew on it. But most of them involved crew for the procedures that we wanted to develop. And we wrote somewhere around 10 to 12 different procedures that we could pick from for these simulations. And I think I wanted to talk about my favorite one. It was the telerobotic operation of a rover on the lunar surface. So crew were sitting in the habitat with the joystick, and the engineers that we were working with developed a simulation of the lunar surface so that we could drive the rover around. And it was fun to work with the engineers. I mean, we started with a boulder field, and these were huge boulders that aren't typical of the environments that we would actually be exploring on the moon. So we had to, iterate with them a few times to get the simulation to work, to look the way that we would realistically expect a rover to be operating, at least initially. And so we got the simulation looking pretty good, good enough for these purposes. And then we helped the crew, we trained the crew on how to run the simulation. We picked specific rocks that we wanted them to go pick up and deliver to an ascent vehicle that would be relevant for later procedures that we had developed. But the crew, sometimes they were pretty aggressive at driving this rover around. I mean, they were trying to be NASCAR race drivers running around the surface, and sometimes they'd get the rover pretty tilted up on these rocks, or they'd get stuck between two rocks and not be able to maneuver out of it, although we let them try for a while. But we really wanted our rocks in these simulations. We didn't have all that much time on the timeline, of course, so if they were stuck in Simland, we could call up the the simulation supervisor on comm, and say, hey, they're stuck, can you get rid of this rock for them? So we had the power of God, basically, in these simulations, and we took it because we wanted our rocks. So anyways, it was a lot of fun to work with the crew and with the engineers and formulate a really strong partnership between science and engineering to go forward and make sure that we can conduct the science that we want to conduct through these future architectures that we're developing. So I did want to share that experience because it is a lot of fun to do this, but it's work and it requires input from the community. So we are using that. I did use that input from the community from the workshop. So look forward into the future for opportunities. This is for everybody, but particularly I'm targeting the early career scientists because I'm an early career scientist. Speak up at those forums and get your opinions out there because we really do use that input. So in closing, I did want to thank you again, SSERVI headquarters, for bestowing this award on me. I'm very grateful, and I look forward to furthering Susan's legacy going forward in my career. So thank you very much.